Hey guys, hope you're having a fantastic day. I'm sorry I'm not there with you guys today, but I had to go to the middle school for a meeting again. I know it always seems to happen on the days I have you guys, but you guys are capable of handling whatever I give you. So today we're going to be talking about ratios and proportions, stuff that we already know how to do. It's just a little bit more advanced in different areas, stuff that we may not have looked at or covered the first time around. So we're going to go through and review all of that again. So ratios can be written as a quotient using a division sign. So like this. Also a fraction, so 7/4. Or as a ratio using a colon, and we say this as 7/4. So the colon represents the word 2. It is easier to simplify a ratio if you first rewrite it as a fraction. So for the first part, the example 2, we're going to write each ratio in simplest form. So to do that, it's easiest to write this as a fraction. So I'm going to write 32/48. And anytime we have fractions, we always have to do what? Yes, simplify the fraction. So if I simplify this, I can divide both of these by 16. So if I divide both by 16, I'm going to get 2/3. All right, so that is your ratio. We could say 2/3, or we could write it as 2/3. All right, try B. So we can write B as a fraction. We're going to write 25x over 20x. Okay, just like we would simplify fractions with variables, we're going to do the same thing. Our x's can cancel. And then I can divide 25 over 20. I can divide both of those by 5. And I will get 5/4. And see, we've done problems just like this before, where we have to subtract the exponents when we're dividing variables. So we're first going to divide out the whole numbers, 9 and 6. So when we simplify that, we get 3/2. Then we are going to look at the x. I have x squared on top, x on the bottom. That cancels. I'm going to be left with 1x on the top. And the y on the top cancels, and I'm going to be left with 1y on the bottom. So my answer for that is 3x over 2y. All right. To write the ratio of two quantities of the same kind. So first, express the measures in the same unit. So we got to convert units. Then write their ratio. So for the first one, we have 3 hours to 15 minutes. So I cannot convert this to hours because I don't have 15 minutes is not enough to make an hour. So the best thing that I need to do is convert my hours to minutes. So if I have 3 hours, I'm going to put that over 15 minutes. I'm going to convert my 3 hours, right? There's 60 minutes in an hour. So I'm going to multiply my 3 times 60 to give me 180 minutes over 15 minutes. So now I have everything converted to minutes. I can simplify. So my minutes, those are gone, right? My minutes cancel. 180 divided by 15. That I can divide both of those out evenly by 15. So I'm going to get 12/1. Or I can write it as 12/1. Okay? So we always have to convert to the same units first. Letter B, 9 inches to 5 feet. So we have to convert everything to inches because I don't have enough inches to make feet, but I do have enough feet I can turn into inches. So we're going to put 9 inches over 5 feet. And to convert that, how many inches do we have in a foot? So there's 12 inches, so I'm going to multiply my 5 by 12 to convert that all to inches. So I'm going to have 9 inches over 60 inches. And then I can simplify. So when I simplify, I get rid of my inches and I have 3 over 20. Or I can write it as 3 to 20. All right. Hopefully this is all review to you. Example 4. Write the ratio of the height of a tree. So we're writing the ratio, the height of a tree 4 meters tall to the height of a sapling 50 centimeters tall in simplest form. So we have meters to centimeters. And we're going to express both heights in centimeters because it's the smaller one and we can convert to centimeters easily. And then we're going to write the ratio. So looking at the first way, I have 4 meters over 50 centimeters. So if we know anything about meters to centimeters, we can multiply the meters times 100 to equal the centimeters. So there's 100 centimeters in a meter. So we can make that be 400 over 50. These are both centimeters now. My centimeters cancel. I can simplify my 400 over 50. Let's cancel out the zeros. I get 40 over 5. So that equals 8 over 1. Or I can write it as 8 to 1. Now I can convert the other way. You know, it's not impossible to convert the other way, especially when we're dealing with this, because we can just add zeros or take zeros away. So the second way, I'm going to convert them both to meters. So this way I'm going to convert both to meters. Just so you can see how I do it both ways. So I again have 4 meters over 50 centimeters. And to convert that, I have to divide this one by 100 instead of multiplying the top by 100. So if I do that, I'm going to be left with 4 meters over 0.5 meters. And when I divide that out, 4 over 0.5 or 4 over a half, remember we can't divide fractions, so we multiply by the reciprocal, which would be 4 times 2, if you think of it that way, or you can put it in your calculator and you will get 8 over 1, the same as we got for converting it all to centimeters. So either way you do it, you should be able to get both answers. It's just some conversions are easy to do, but these ones up here, it doesn't make sense to convert them all to hours because it's going to be such a small amount for the hours. 15 minutes is such a small amount. It's not impossible. We can do it, but it just doesn't make sense to do that. All right, when you solve a word problem, you may need to express a ratio in a different form. If two numbers are in the ratio 3 to 5, you can use 3x and 5x to represent them because 3x over 5x is the same as 3 over 5. So here we're going to look at Jenna, and she's planting alfalfa and wheat on 160 acres on her farm. If the ratio of acres of alfalfa to acres of wheat is 3 to 5, how many acres of each crop are planted? So we can think about what it said up here. Okay, when you have the ratio 3 to 5, we can use x's and replace to figure out, do we know the number of acres? Nope, so we can use x to represent that. So we're going to let x, or not x, we're going to let 3x equal the number of acres of alfalfa. And we're going to let 5x equal a number of acres of wheat. So now it wants to know how many acres of each crop are planted. So this is what we're looking for. How many acres of each crop are planted? So we know that there's a total of 160 acres. And I know my ratio is 3 to 5. So I'm going to add the number of acres of alfalfa to the number of acres of wheat, and that has to give me 160 acres. So this is going to look like this. 3x plus 5x equals 160. And then we're just going to combine like terms and solve for x. So 3x plus 5x is 8x equals 160. Divide by 8. And then x equals 20. Excuse me. So we're not quite done yet. We know what x is, but we have to plug that back in and find out the actual number of acres that we have. So we're going to plug in 3 times 20 for alfalfa, and that gives us 60 acres of alfalfa. And then I'm going to do 5 times 20, and that gives me 100 acres of wheat. 100 plus 60, yes, that adds up to be 160, but the question is it a 3 to 5 ratio? So we always have to check, is that a 3 to 5 ratio? So let's put it in the ratio form. So if I have 60 over 100, and I simplify that, I get 6 over 10, and that I can divide both of those by 2, I get 3 over 5. Yes, 3 over 5 is a 3 to 5 ratio, and that checks. So I can verify to make sure that that makes sense and that it is the same ratio as what we needed to have in the first place. All right, example 6. The lengths of the sides of a triangle are a ratio of 3, 4, 5. The perimeter of a triangle is 24 inches. Find the lengths of each side. First of all, we have a 3, 4, 5 ratio. So that means we can let 3x, 4x, and 5x be the side lengths. So I can let those be the side lengths. The perimeter means, so if I have the side lengths, I'm going to have 3x, 4x, and 5x. And I know this ain't the same, it's not the drawing to scale. It's just kind of giving me an idea of what it's going to look like. The perimeter is I have to add up all the sides. So that means I'm going to have 3x plus 4x plus 5x. And all of those, the perimeter of the triangle is 24 inches long. So that has to equal 24. Combine your like terms. So 3 plus 4 plus 5 is 12x equals 24. Divide both sides by 12. So then x equals 2. Well, I'm not finished. I still need to find the side lengths. So I need to plug it in. So 3 times 2 is 6 for the first one. 4 times 2 is 8. And 5 times 2 is 10. So when you look at the ratios to this, a 3, 4, 5 as opposed to a 6, 8, 10, is that equivalent? So if we divide each of those by 2, right, because we multiplied them by 2, we're still going to get back to the 3, 4, 5. So it is equivalent. It's an equivalent ratio. It does equal the same thing. Okay? All right, proportions, something that we have looked at and talked about before. So ratio is comparing two or more things. So a ratio compares two or more things. A proportion is an equation that states that two ratios are equal. So it's an equation, they have to be equal. So we have two ratios, A to B equals C to D, or A over B equals C over D. So we're taking our ratios and we're setting them equal. The extremes of these, A and D, so A and D are your extremes, and B and C are your means. So what this is saying here, to solve proportions, you're going to cross multiply and set equal. So if A over B equals C over D, then A times D equals B times C. So that means your extremes, multiplying your extremes, the product of extremes equals the product of means. So the product of extremes equals the product of means. All right, and that's just information. We won't really talk a whole lot about those right now. We'll talk about extremes and such at a later date when we get more into the extremes. But we did see it a little bit when we were talking. No, maybe we didn't. We haven't seen it yet. We haven't really talked about extremes or means yet. All right, solve each equation. So we all know how to solve proportions. At least we should all know how to solve proportions. Remember, we cross multiply these. So I have 5 times x is 5x is equal to 3 times 4, which is 12. It doesn't matter which side I multiply. I could have it 12 equals 5x. It doesn't matter which order I put it in, as long as I have the right numbers multiplied. So I have 5x equals to 12. I can divide both sides by 5, and I get x equals 12 over 5. I may have you guys write that in decimal form, so you'd have to divide it out, 12 divided by 5. I might have you put it in decimal, and you would say it was 2.4. I may not. I might have you just leave it as 12 over 5 because I don't want you might not be able to use calculators. So I would just have you leave it as a fraction. All right, for B, remember we can just put 8 over 1, cross multiply, we get 8n equals 3, divide by 8, so n equals 3/8. Number 4, cross multiply, this negative is going to go with the top number. It doesn't really matter which number it goes to because if one's negative, it doesn't matter. When you divide it out, you're going to get a negative answer anyway. So it really doesn't matter, but I always just like it to keep it on the top. That way I don't forget about it. So we have 15a, or 4 times 15a is equal to negative 2 times 21. So 15 times 4 is 60a is equal to negative 42. Divide both sides by 60. And then simplify. So a equals negative 42 over 60. I can simplify those. If I divide by 2, it's going to get me somewhere. But If I divide by 6, it's going to get me somewhere quicker. So then I'm going to get A equals negative 7 over 10. Or negative 0.7, 7/10. So either one of those answers will work. All right, D. Notice a lot of these are fractions. So D, we're going to cross multiply. We get negative 6 times 3x is equal to 12 times 3. Negative 18x equals 36. So I can divide by negative 18, and I get x equals negative 2. All right, so that was the easy part of solving proportions. Now we're going to get it a little bit harder as we go through these. So we're going to be solving each equation. We have already done these before, so this is really still nothing new, nothing that we haven't already done. And so we just need to remember the process. So cross multiply. Remember, this is in parentheses, so we need to keep that together and multiply it. So we'll have to take 15 and multiply it to x minus 4, and that's going to equal 6. We're going to distribute the 15 to both sides, or to both numbers inside the parentheses. So I get 15x minus 60 equals 6. Add 60 to both sides. 15x equals 66. Divide by 15. X equals, and then we can simplify, 22 over 5. So if we divide both by 3. All right, B. Now we have two problems we're going to distribute. So we're going to have 6 to n minus 3 is equal to 5 times n plus 2. Distribute. So 6 times 2 is 12n minus 18 is equal to 5n plus 10. I have variables on both sides, so now I'm going to have to move all the variables to one side, everything else to the other. So I'm going to subtract first 5n from both sides. I get 7n minus 18 equals 10. Add 18 to both sides. And you guys can do that all in one step. I normally do, but because I'm reteaching it and making sure you guys understand it, I'm keeping them separate. So you can cross off that. We get 7n is equal to 28. Divide both sides by 7. So then n equals 4. Okay. And for C, we can put this over a 1. And when we multiply, cross multiply, we get 11 times 2x minus 2 is equal to 5x times the quantity x minus 3. Distribute, so we get 22x minus 22 is equal to 5x minus 15. You can subtract 5x from both sides. Oops. And you get 17x. And we can add 22 to both sides. So then we get equals 7, positive 7. Divide both sides by 17. And x equals 7 over 17. We cannot simplify that any further. All right, so hopefully you remember how to do the proportions. They're not too difficult. You guys should be able to whip right through those fairly easily. The last couple problems that we're going to be looking at are word problems. And so with these, it's just a matter of setting them up in the right order. So we have a 5-pound bag of flour. Cooking class can make 120 date nut muffins. How many muffins can they make with a 2-pound bag of flour? Is your answer reasonable? Explain. So first of all, when we're setting up proportions, we need to set up flour to flour, and total to total. So if I look at this, I'm going to start with my 5-pound bag of flour. So 5 pounds on the top gives me 120 muffins. Okay, and that's going to equal a 2-pound bag of flour over, and I want to know how many muffins that can make, so I'm going to let X represent the muffins. So now I can cross multiply just like I normally would. So if I cross those, I'm going to get 5x. So I'll write it over here. 5x equals 120 times 2. So then 5x equals, oops, doesn't want to write, equals 240. Divide both sides by 5. So then x equals 48. 48 muffins. Label your answers. Question is your answer reasonable? Does it make sense that 2 pounds of flour was able to make 48 muffins? So when you think about it, 5 pounds to 2 pounds, think about your ratio. Okay, so 5 pounds is a little over half, right? So what we need to look at is about how many is half of the muffins. So if we think about it, a 5-pound bag can make 120 muffins. So about half of that would be 60 muffins, right? So half would be 60 muffins, and it only made 48. So half of a flour would be 2.5, but we only have 2 pounds. Does it make sense that that only makes 48? And the answer is yes. It makes sense because half of them will be 60 muffins, and that's less than half the flour, which would be less than half the muffins. And so since 48 is less than 60, that does make sense. All right, example 4, last one, we're almost done. About 8 gallons of gas filled the tank after Greg drove 224 miles. How many miles can he expect to drive on a full tank of gas at about 13 gallons? Is your answer reasonable? Explain. So on this one, I'm going to think about it a little differently because I always think of miles per gallon instead of gallons per mile. And so I'm going to put my 224 miles on top because we're talking about 224 miles per 8 gallons. And that just makes sense to me because we're kind of trying to make sense out of these things. So it doesn't really make sense to say 8 gallons for 224 miles, but it does make sense to say 224 miles per 8 gallons. So that's just how I'm setting it up. And that's going to equal x, which is how many miles can I expect to drive, is x, at about 13 gallons. So now I have my proportions set up. I can cross multiply those. So I have 8x equals 224 times 13. So 8x equals, and if we multiply that out, 224 times 13 is 2912. Remember, if you have to multiply it out longhand, write it out. Okay, I can divide by 8. So then x is equal to, and if you don't remember how to divide longhand, we're going to be doing that next class, but with variables. So we can divide it out. Remember, the top number goes in the box, and 8 goes on the outside. And we can say 8 times 3 is 24 with 5 left over. Bring down the 1. 8 times 6 is 48. That equals 3. Bring down the 2. And then 8 times 4 is 32. So x equals 364 what? So that is miles. So how many miles we can go? 364 miles. Is your answer reasonable? So we can say, yes, my answer is reasonable because 13 is not quite double the amount of gallons. And 448 would be double miles. So 364 is less than 448. So it does make sense. Okay? All right, that is all I have for you today. So you only have 20 problems for homework. The homework problems are marked in the top corner of your note sheet. So if you can find that on your note sheet, you should be able to get started on your homework with plenty of time to get everything done before you leave class. Okay? Have a great day. I'll see you guys on Thursday.